Alright, welcome back to another class. So we're going to be dealing with exercises on projectiles. Alright, so we have 4 questions we'll be solving. As usual, you can solve them first before completing the video. Okay. Of course, the questions you can find in the PDF in the description. Okay, so let's move on. The first question says, a ball is projected horizontally from the top of a hill with a velocity of 30 meters per second. If it reaches the ground 5 seconds later, what is the height of the ball? So if we're to write down the information we have from this question, we have our initial velocity to be 0 meters per second. All right. The ball is projected horizontally from the top of a hill. All right. So before it's projected, it was still. It was not in motion. So our initial velocity is 0. Then our time is 5 seconds. We are asked that if it reaches the ground 5 seconds later, what is the height of the ball? So our time is 5 seconds, velocity is 30 meters per second, and then we're asked to find the height. As we can see, the ball is projected horizontally. So which of the formulas do you think we can use to solve this problem? I would go with h equal to ut plus half gt squared, because we have our initial velocity, we have gravity, and we know our time. So we can find the height quite easily. Alright, so this will be 0 plus half 10 meters per second squared times 5 seconds squared. If we simplify that, we're going to have 0 plus 125. Okay, so 5 squared is 25. Multiplying that by 10, we have 250. Dividing 250 by 2, we have 125. So this means our height is 125 meters. Alright, so let's get the second question. A body is projected upwards at an angle of 30 degrees with the horizontal at an initial speed of 200 meters per second. In how many seconds will it hit the ground? Then how far from the point of projection will it strike? So we have 2 questions. The first one, we're asked to find time. Okay, the next one we're asked to find the range. Alright, so we can do this by first listing out the parameters we have from this question. So first of all, we have our angle of projection at 30 degrees. We have initial velocity at 200 meters per second. So you can see it's stated here. It was projected at an angle of 30 degrees with the horizontal at an initial speed of 200 meters per second. We have gravity as 10 meters per second squared, and we're asked to find t, the time it will take to hit the ground, as the first question. So we can use the formula for time of flight, which is 2u sine theta over g. Alright, we have our initial velocity, we have theta, and we have g. So if we bring in those parameters into the equation, of course we'll have 2 times 200 times sine 30 over 10, which automatically gives us 20 seconds if we simplify all this. We have to find the range, so we use the formula for range, which is u squared sine 2 theta divided by g. Okay, so we'll put in the parameters into the equation. So we have 200 squared times sine 2 times 30 divided by 10, and that will give us 3464 meters. Okay, so let's look at the third one. The projectile is fired horizontally from a gun that is 45 meters above flat ground. Emerging from the gun with a speed of 250 meters per second, how long does the projectile remain in the air? B. At what horizontal distance from the firing point does it strike the ground? C. What is the magnitude of the vertical component of its velocity as it strikes the ground? Alright, so we have 3 questions. So let's start with getting our parameters from the question. We have our height to be 45 meters above flat ground. Okay, initial velocity, we have it to be 0. Okay, then the speed, we have it to be 250 meters per second. Now, there's something you have to note here. Remember, this projectile is fired horizontally from the ground. These questions are actually easy if we can understand what they portray. Okay, so we are asked to find the time it will take for it to hit the ground. Okay, now if you look at this carefully, you agree with me that if this is the projectile leaving the gun and hitting the ground seconds later, okay, if this is the shape of its motion, you can agree with me that this projectile moves in two-dimensional. It's a two-dimensional kind of motion. You have motion in the x-axis, all right, and we have motion in the y-axis. Okay, now we're asked to find how long it takes for it to move from this place and hit the ground here. Okay, So what we're actually considering, or what matters to us here, is how long it will take for it to close up this vertical distance. All right. So at this initial place, we will take our initial velocity as 0, because at this, in the vertical, there is no speed in the vertical at this point. Remember, it is projected horizontally at a speed of 250 meters per second. So the horizontal speed is what was given to us as 250 meters per second. All right. But then there is also a vertical speed, because at this point, when it was shot, vertically the speed was 0, but the speed, as it keeps coming down, vertical speed increases till it hits the ground. When you talk about vertical speed, the initial speed was 0. Okay, so if you have that understanding, then we can now go to solve the problem, and we'll solve this problem using the height formula. So h equal to ut plus half gt squared. All right, so our height is 45 meters. Our initial velocity is 0, so t here becomes 0. Then we have half, which is 0.5, times gravity, 10 meters per second squared, times time raised to power 2. Okay, so now we can simplify this to get our t. Okay, I just hope you understand this whole talk about the vertical motion and the horizontal motion. Once again, let me just repeat. Remember, the projectile is fired horizontally, and the projectile emerges from the gun with a speed of 250 meters per second. That's the horizontal speed, but not the vertical speed. At the initial spot, it moves in the horizontal direction alone and doesn't move in the vertical. It's after a few split seconds it starts moving in the vertical. So our initial velocity for the vertical is 0. Okay, so that's how we got this. So if we simplify this, we're going to get t squared equal to 45 meters divided by 5 meters per second squared, and then that will give us the root of 9 seconds squared if we find the square root of both sides. Okay, and that's 3 seconds. So it's going to take 3 seconds for this projectile to hit the ground. So when I asked at what horizontal distance from the firing point does it strike the ground, so that's B. So we can simply we know the velocity. Okay, we know the velocity is moving at, and we already know the time it's going to take to hit the ground. Okay, so we use that to solve for the distance. Okay, so of course distance is equal to velocity times time. So we have 250 meters per second times 3 seconds, which will give us 750 meters. Okay, so this is quite simple. If they're asking about the horizontal distance from the firing point, like what horizontal distance will it strike the ground? You know, this guy started at 250, and we've already known that at 3 seconds this stone will hit the ground. So it means it's going to be in motion for only 3 seconds. It will hit the ground. They're not asking what is the distance this thing will cover in that 3 seconds. Okay, the initial velocity is 250, and the time is going to take to get to 0 point is 3 seconds. So with that, we can find the distance, which we have done. Okay, so the third one, what is the magnitude of the vertical component of its velocity as it strikes the ground? So what is the velocity at this point just before it strikes the ground? We come back to the vertical motion now. So we know the initial velocity is 0. We are about to find the final velocity before it hits the ground. Okay, we know the height is 45 meters, and we know the time is 3 seconds. So we can use v equal to u plus gt squared. Okay, because the motion is in line with the force of gravity, so it's positive here. All right, so this will give us 0 plus 10 meters per second squared times 3 seconds, which is 30 meters per second. So we look at the fourth question. Okay, a certain aeroplane has a speed of 290 kilometers per hour and is diving at an angle of 30 degrees below the horizontal when the pilot releases a radar decoy. The horizontal distance between the release point and the point where the decoy strikes the ground is d equal to 700 meters. Now, how long is the decoy in the air? And b, how high was the release point? So first of all, we need to understand that our angle of projection here is 30 degrees below the horizontal. Okay, so these are parameters. We have 30 degrees as our angle. Okay, so you can see the diagram here. So this is the horizontal, and this is where this thing was projected, and theta there is 30 degrees below the horizontal. So our initial velocity, okay, because our initial velocity is the velocity of the plane, because that's the projectile was in motion with the plane before it was released. All right. So if you look closely, you see it was not shot. It was just released and not shot. Okay, there are two different things. If it was shot, we'll consider the additional velocity that the gun gave it, okay, and probably add it to the motion of the plane. But in this case, it was not shot, it was just released. It will definitely have the same initial velocity with the plane, which is 290 kilometers per hour. Let's remember that for the formulas, the final formulas we're given for projectiles considered a projectile motion of this nature, okay, where you start at the projectile starts at a point, moves from that point to a maximum point, and then starts coming back down to the ground. Now, but the thing with this question and the previous question is that this projectile starts from the high point heading down. Okay, so if we use those formulas that we're given, those final formulas we have, we will not be able to get accurate answers because this projectile is only doing half of the motion those formulas consider. Okay, so having said that, in the previous question, we had to deal with vertical distance and vertical velocity. Okay, so our vertical initial velocity was 0 in that question. All right, so that's why we used 0 as initial velocity. In this case, we are considering horizontal, and the initial velocity of this horizontal motion can be gotten by finding the horizontal component of the velocity, which is u cos theta. Okay, so we're going to be having range equal to u cos theta times t. This formula was part of the part of the equations we got while we were deriving the equation for range. If you go back, you will see that this was this part of the steps we used or we passed to get to the final formula we have for range. So our initial velocity here is, of course, 290 kilometers per hour. All right, so we find the horizontal component of that velocity, and that will give us 700 meters, which is range, equal to 290 kilometers per hour times 1000 over 36. Okay, and this is going to help us change this whole kilometer per hour to meters per second. All right, then we multiply this by of course cos theta, because this is the velocity multiplied by cos theta times time. Okay, we make t the subject of formula, and we have this. So if we simplify 700 divided by 80.6 times cos 30, we're going to be having 10 seconds. So it's going to take it 10 seconds to hit the ground. So let me go over this again. For projectiles, we need to understand that you have vertical motion and have horizontal motion going on at the same time, because it's two-dimensional. Okay, so you can have a vertical component of velocity and a horizontal component of velocity at any point in time. Now, these questions don't involve the full parabolic shape of the projectile. All right, this whole question deals with just half of the shape. Okay, so this projectile is released from a plane at this point, and it gets to the ground at this point. We have the horizontal distance, we have the velocity, okay, and we are asked to find how long it's going to be on the air. Okay, so there's a vertical component to the velocity it has, and that component is highly influenced by gravity. But then there's a horizontal component to the velocity it has. If we're dealing with the horizontal distance, okay, it's wise that we consider the horizontal velocity, the velocity effective in the horizontal direction. All right, that will give us the accurate amount of time this object will stay in the air, considering the horizontal distance. So that's what we did here. All right, for the second question, how high was the release point? So we're now dealing with the vertical. We're now dealing with the vertical distance. Since we're considering how high, for our initial velocity, we're going to be considering the vertical component of the velocity. All right, we're not just going to use the tangential velocity. We'll consider the vertical component of the velocity because we're considering height. Okay, we have the time already. Okay, so we can use the formula h equal to ut plus half gt squared. All right, where u, initial velocity, is 80.6. Remember, we've gotten this 80.6 here when we converted kilometer per hour to meters per second. So we have 80.6 meters per second times sine 30. Sine 30 because we are trying to get the vertical component of that velocity. All right. I'm sure we're used to that by now. Okay. We know that when we're dealing with vertical component, we do sine theta. If that theta is the angle the component mixed with the x-axis, so we can see that theta here is the angle with the x-axis, so we do sine for the vertical component. All right, so if we multiply that by the time 10 seconds, and then we have plus half gt squared. If we simplify all that, we're going to have 403 for this side and 500 for this other part. We sum that all together, we have 903 meters. All right,